Hi everyone, this is Andrew Hoffman, hopefully your favorite cybersecurity YouTuber who occasionally does non-cybersecurity related content. Today is one of those days. So about a year ago, I released some tutorials on the open source game engine Godot, and those were on the version 3.x.x version of that game engine, and they were quite popular. I think one of them got about 100,000 views already. And in those tutorials, I just want to walk people through how to build a game quickly. What do you need to know to get started and get running with this game engine? Well, now Godot 4.0 is out, so I wanted to do the same thing. Today we're building a roguelite game. So I'm going to just show you real quick what this game includes, and it's in the Godot 4.x.x, in this case 4.0.3 stable. Ultimately, this is going to be everything you need to get started building a game, somewhat akin to maybe Wizard of Legend, which is a popular roguelite game. Have a home base, you go into a dungeon, you collect currency, come back, upgrade your character, and progressively go into the dungeon over and over and over again until you become skilled and powerful enough to defeat the bosses in that dungeon. So I'm going to click Run the Project. Now if I maximize here, you'll see that I'm actually in the dungeon right now. And in the dungeon part of this game, I have health at the top. You see I'm getting hit by these enemy projectiles. There is an enemy denoted by NPC. He is chasing me, so he has some basic AI built on heuristics. He is firing projectiles at me. If they hit me, they reduce my health. If it goes to 0, I die. I have mana here, which I can click the key number 1 and fire projectiles. And if I hit him several times, I will defeat the NPC. So now I've defeated the NPC and he has dropped loot in his place. This loot says G, which stands for gold. Now, in the way that I've constructed this game, gold is a currency you use in the dungeon, but it is destroyed as you leave it, and crystals you can carry out of the dungeon to upgrade your character later on. So to recap, we have health, mana, gold, crystals, so we have several currencies, enemies with AI, and abilities. In this case, I only have one ability coded, which is this projectile fireball, and I am in this dungeon. Now, the other part of the game loop for a game like this, a roguelite, is often you have a home base, and this time I just called it home. It's over here. Now, if I want to load a different scene in Godot, what I do is I go to settings, I go to run, and then I just swap it out by going to scenes, home. So now I click play again, and now I'm at the home base. Now at the home base, you'll notice that there's an NPC down here, but he doesn't attack me or anything. He's in fact friendly, and I can talk with him, so there's a little bit of a dialogue started. If I click the interact button, which I've keyed to F, you'll notice that down here in the console I get hello from blacksmith. And so my idea was maybe a character that would upgrade your gear or something akin to that. But this is just a framework for a roguelite, so the idea is you learn everything you need to know here, you can go build your own game, and then you can take it from there and post in the comments what your ideas are or what you've accomplished using this as a stepping stone, a starting point. So how did I build this? Well, this took me about 2 hours total over the weekend, and it only took me 2 hours because I know a little bit from Godot version 3 that I was playing with last year, and I also have quite a bit of experience programming. It might take you a little bit longer, that's fine, I won't worry about it. The Godot game engine is really easy to pick up compared to other more complex game engines, like for example Unreal. I'm not a game developer, I am just someone who knows programming and a number of other technical things, and I picked this up for fun, so I had something to play with on the weekend, and I built the scaffold for a roguelike game. On the left here, you'll see that you have all your files and folders. I have a folder called Assets, Scenes, and Scripts. I have another video from about a year ago. You can search on my channel for Godot. It's called something like How to Organize Your Godot Game for Scalability, something akin to that. Watch that if you're interested in learning why it's structured this way. But for now, I'm going to unfold all of these, and you'll notice under Assets, the main thing to worry about right here is I have this dev assets.png, and it just has a whole bunch of squares, and I believe these are 16 by 16 squares, and there's a 320 by 320 file. I believe it's a PNG file, yep. And so what I did this time around was, instead of working on getting pretty art into the game, I just started with programmer art, which is just colors, just squares of solid colors. Now I have another video, I think it's called top-down 2D Go.RPG, or maybe it's 2D side scroller in 15 or 20 minutes, and it's a similar type of tutorial. And in that I walk through how to get pretty art, pixel art for free that people have released on the web under good licenses that you can use in your game if you're not an artist. So if you want to follow through this tutorial and then make it look nicer, you can check out my Godot games on YouTube. But for now, we're going to jump past assets because that's all you need to know about. And we're going to look at scripts and scenes. So I architected this game a little bit uniquely. you'll see that I have a script called gamemaster.gd. And what I want to do is, one concept in a roguelite is you're often going through dungeons and portals and fighting enemies on a variety of maps. Now, what you could do is you could hard code spawn points in all of these different maps, but that's just a little bit of a headache. So what I did was I created this script Game Master, something akin to maybe a Game Master in the game Dungeons & Dragons, so it has a lot of control over the game, and these are universal controls, universal function calls. Now in Project, there's a tab called Auto Load, put scripts here, and then if you click Enable Global Variable, what's going to happen is you'll be able to reference these scripts in-game, inside of your scripts, by their name. So what does that mean? This script is called Game Master and it's always loaded, and any other script can reference it just by saying Game Master dot whatever they want to say. So if I wanted to get the current player, I say Game Master dot get current player, Game Master dot spawn current player, spawn other player if I'm creating a multiplayer game. This was something I was playing around with. And so a lot of functionality that I think is common to all of the levels within this game, I'm going to throw in the Game Master class. That's just how I've chose to organize it, because I don't think it's going to be a game that's so complex where this is going to become a bottleneck. But for example, if I want to spawn the player after the player's died, I call this function, and I'll show you where that appears later on. So let's start over here in home. .tscn files are Godot scenes, and Godot scenes are comprised of really two things: nodes and scripts. So what is a node? A node is basically a placeholder for data and script, but there's multiple types of nodes you can use. So you can see home, this is a node 2D. I can hierarchically add nodes to a node, so I can click Add Child Node. And I have all these predefined nodes within this window. And the idea is some of these nodes come with functionality out of the box that Godot is providing, or you can just use a generic node like Node2D and you can code all of your own functionality on it and attach it as a script like this. So as you can see right here in home, on ready is a function that Godot is going to call whenever this node loads. It says gamemaster.spawn current player. So that's how the current player gets into the game. So we go, the new node says gamemaster.spawn current player. We jump down to scripts. We go to game master, spawn current player. Now if the player's already spawned, we don't do anything. Otherwise, we use this load function. We load in the player scene. We instantiate the player scene, and we set up some data and just drop it at position 0, 0. In this case, that'll probably change in the future. In my prior tutorials, you'll notice that you need a camera. Well, I'm doing the same thing here. I'm dynamically creating a camera, and the camera is what displays the map for you. And so as we boot up this game, what's going to happen is in this home scene at position 0, 0, the player will get spawned, and around the player, attached to the player, will be a camera. And that's why whenever I move, the camera follows, is because right here I'm actually saying create the camera, and then I'm adding the camera as a child to the player node. So it's always going to follow wherever the player is positioned. I also load in a HUD. So what's a HUD? It's just a UI. I think it stands for heads up display. If I go to the UI folder over here, I have a HUD, and it's just another scene. So like I said, a scene is just a collection of scripts and nodes. This UI node is nothing different. We have some built-in nodes, like this is a canvas layer, which is a new rendering layer. We have some, like perhaps a node 2D here. And then importantly, right here we have a rich text label. Now we look at the script on this. Well, how does the UI work? Well, the UI, it looks like it extends node. There's some data up here, but most importantly, there's a function called getDebugText. This says getParent.getState. So it's calling a function called getState on the parent class, which is always going to be the player because we're only attaching it to the player. Saying getParent.gold, getParent.crystals. Okay, so how's this working? Well, if we look at the player, we notice in Game Master that we're spawning, let's see, entities/player. So let's jump over to entities and let's look at player. Now, the player is a scene, has a collision shape and a sprite. So it just has, you know, that blue character and a collision shape. So Godot knows that when it hits something that is collidable, it will stop. And then it has this script attached up here. And this script has some data, gold, crystals, etc. And you'll notice it also has some abilities it's pulling in. Like for example, we were shooting a fireball, and I also coded the movement as an ability so that maybe some characters could have movement, others could be stationary. There's a read input function, and you'll notice that on the physics process we're reading the input. This is how we're taking input from the user to move left, right, or fire abilities. So we create an array of movements, and then depending on what you're clicking on the keyboard, and these correspond, up here you can set them. So we go to project settings and we go to input map. And so for example, W right here corresponds with move up, move down corresponds with S. So we'll say move up right here. We append up to movement. Then what we do is we call this ability called move. So move right here, it's just another scene, yes, but it also has a script attached to it. And this scene works with the velocity in the same way that my previous tutorials have done. One thing to note is you'll see it says s.velocity. It doesn't create a new velocity variable. And the reason why is because characters now have a velocity object built in. So whenever you're working with, let's see what this is, it extends entity. Entity is kind of like a class for describing a character. Yeah, so character body 2D. In Godot 3, you had to define velocity yourself. Now character body 2D comes with its own velocity. So when we want to move it around, all we got to do is pass through S, which refers to the player or the NPC, it could also be. And then we're just going to set their velocity back to 0, 0. And depending on the inputs that we got in this array, which defaults to empty, we're going to move them around in the correct directions. So that's movement. We're talking about player still. And what else does the player do? Well, you'll notice that there's actually a global cooldown here. So it says if last ability is greater than global cooldown. How does that work? Well, one issue is if you're trying to interact, let's say you're holding down the interact button, in this case is F, your process is going 144 times a second. You're going to try to interact 144 times with the same NPC. And really what you want to do is probably interact once. Last ability and global cooldown, these are keyed in, I believe, in the entity class over here. So we have global cooldown 30, is busy, and last ability. And the idea is what we do, and I'll even find it somewhere around here. Let's try to find the interact, if interact is keyed in here. It might actually be on player. Let's jump back to player. Okay, so read input interact. Okay, here we go. So number one, do we have collisions? Is the player colliding with something else? Number two, is it an interactable object? So we have to define if an object is interactable by going to its class. For example, that blacksmith, we can click on it, go to its script right here, and we've added it to the group called interactable. So whenever we say get groups blacksmith, it'll have interactable as one of its groups. Okay, so we know it's interactable. So then what we're going to do is we're going to call c.interact. So this is get collisions, and so we're going to get the collision here, and then we're going to call the interact function on the blacksmith itself, which is going to print hello from blacksmith. And that's kind of how you can scaffold a dialogue system, is by checking if you have collisions with any enemy that has been annotated as interactable. Just make sure an interact function on them, because if there's no function, it will throw an error and crash. Okay, so back to the player. So this is how we perform our interactions. Now, when we say underscore get collisions, collisions is up here. You can read that on your own time because getting collisions is really well documented in Godot. Ultimately, you just call this function get last slide collision, and then we're going to just see if we actually have a collision, so it's not empty, not null, and we're going to return it. But you can read up more on collisions on your own. You won't have any issues finding that, but this is how we interact. And then I was talking a little bit about a global cooldown. So we set this last ability to 0 after we interact, and then we jump over to the entity over here. Let's see, what do we have in entity? Last ability. Let's do a control C, control F, last ability, and let's jump down. So when we're calling get state in the UI, this is actually what we were returning. So this is just a JSON helper object to return a bunch of data in regards to the current user for the user interface. And you can see it's all getting pulled from this entity file. So that means any entity could make use of it. Now, if we go to the physics process, we're incrementing last ability by 1 every time the physics process ticks, which is 60 times per second, which means that if we have a global cooldown set to 30, every time the physics process ticks, last ability goes up by 1, and we prevent the user from activating an ability unless last ability is equal to or greater than global cooldown. What that means is you'll only be able to use an ability once per half of a second or twice per second. And that protects you from those scenarios where you might accidentally click on a interaction and then interact 150 times in a second because you don't have a limit there. So that's kind of important. And then stepping off of that, let's talk a little bit about abilities. So the way I've coded abilities in this, we already looked at move, is abilities are kind of their separate scenes. And I think I have a modular abilities tutorial you should check out. But ultimately, you know, this is an ability called Fireball. And if I go over here and I look at Fireball, you'll see there's several things here. Well, we're actually loading in an ability called Fireball using a function called load ability. Now, if we go to entity and we go down to, let's see, load ability, it's going to take in the ability name Fireball. It's going to reference the scene Fireball /fireball.tscn, the Godot scene. It's going to instantiate it and add it as a child node. So we go here, the first place we end up is Fireball. This is just a node 2D. It doesn't actually have anything attached to it. So this is really attaching a Fireball controller. You could also call it Fireball controller. This itself, Fireball, is not Fireball entity, and the reason why is because we might want to cast multiple of these and we don't want to load it every single time. We only want to load it maybe once per. So when we load this Fireball entity in, what it's going to do is it's going to reference the current controller. So as you load it in, you're passing through a reference to yourself. It's going to see if you have the mana to cast a Fireball, and if you do, and if you click it, what it's going to do is it's going to instance the Fireball projectile. It's going to, of course, instantiate it. It's going to position it correctly. And right here, this is very important for projectiles in Godot. If your projectiles have collision, you want to make sure they don't collide with you if you're spawning them on top of you. So you could do a little more math and you could spawn it in front of your character, and you'll see what I'm talking about right here. So if I click ability number 1, you'll notice that it actually spawns behind me. Now if it as a collidable entity and myself, the player as a collidable entity, collided with each other, then it would create, I think, 60 different collisions a second, and neither of them would move and we'd both be stuck because it's a 2D game in 2D space, and we'd be constantly colliding 60 times a second with each other. That doesn't make any sense. We want it to collide with our enemies. Now you can see I'm out of mana, so it's giving me an error in the console here, not enough mana, because we did do that can cast ability mana cost, and that's inside of the entity class as well. And it's very simple. We check the character, we see if the character has equal to or greater than mana than the required mana cost, which is denoted here as, and then if it passes, we fire. If it doesn't pass, well, no more Fireball projectiles. So that's kind of the basics of how projectiles work here. You'll notice here's the projectile itself. It has damage and it has speed. So when the projectile controller, the Fireball controller, gets called, what it's going to do is instantiate a Fireball projectile, and the projectile actually handles its own movement and collision and despawning. So it's basically going to say, hey, I'm going to go in a particular direction until I collide with something. Now if I collide with something that has the group of entity, so it's like a living thing, then what I'm going to do is I'm going to try to apply damage, and of course I'm going to print the damage if I have to. And then after I've applied damage or I've met another condition, for example, maybe I've hit a wall, or the Fireball's been flying for a certain amount of time. You can see there's a timer right here on line 15, await tree.createTimer2, that says if the Fireball doesn't hit anything within 2 seconds, just explode it. And if it does hit something, explode it too. And in this case, exploding doesn't create an AoE effect. It could, but really what it does is it just tells the garbage collector to remove it from memory and move on with the game. And by doing that, you'll notice right here, if I shoot a Fireball at a wall, it just despawns when it hits a wall. And I felt like that was the easiest way to handle it for this simple use case. Same thing with NPCs. The difference being NPCs will actually take damage. And you can see that if I jump back over in project settings and I go to general run and I go back to the dungeon scene. Now I believe the Fireball does 10 damage, and I think this NPC here 20 health. So if I hit him with 2 Fireballs, well here first, if 2 Fireballs hit each other in air, so the idea is if a projectile hits each other in the air, they're going to explode too. So if we time that correctly, we can actually cancel them out. And there's more complex ways you could deal with that. Perhaps a more powerful ability would break through a weaker ability, but in this case I thought that was a cool way of handling it. Now if I shoot another projectile, you'll see of course that NPC despawned, so he has faded into the abyss, he is dead, and he left a coin behind. I'll pick up that coin and get my gold. But ultimately that's how I have structured this ability system. So what do we have here all in all? Well, if I was to summarize how to build a roguelite using Godot 4, here's what you need. So you need assets. You need some type of images representing a number of things. A player, a projectile, you need flooring, you need enemies, gold and crystals, some type of currency, and of course walls. And the walls, what we're going to do with the walls, like I mentioned, inside of our scenes, let's go to home. We need a home scene and a dungeon scene. We're going to have this tile map that contains a tile set, and inside of the tile set object, we're going to go to select, we're going to click on it, we're going to go to physics layer, and we're going to highlight using this tool right here for highlighting collision. We're just going to fill it all the way up. So we want the whole entire square to be collidable, and because it's collidable, that means our player inheriting from, I believe, character body 2D will not be able to pass it. So there we go, we have collision on walls. And of course don't put it on the floor so you won't be able to move. You also want to do the same thing to NPCs, whether they're friendly or not friendly. Next, what we want to do is in our home scene, double click the home scene right here. you probably want some amount of NPCs there. In this case, you'll notice that right here I have an NPC which is stored in scenes/entities/blacksmith, and all I did was drag and drop this scene into my home scene, and you can take any amount of scenes you want and you can put them inside of other scenes, and it's just a method of organization for organizing your nodes and scripts in a simple way. Now this NPC, he has a collision shape like I discussed. He has a sprite, and that sprite is just the NPC object from the assets dev-assets.png. It's the NPC square, so it just colors with the text NPC in it, and I made it in Paint. He also has this script. The script's the most important thing. He adds himself to the interactable group. He actually doesn't add himself to the entity group because the entity group can take damage, so I believe in this case he's invincible. Don't forget right here super._ready, because the function ready in Godot does a number of things off the bat, and if you don't call super, if there's a parent function called ready, then none of that functionality be called. So what you want to do is whenever you implement ready or physics process, in most cases you're going to want to call, see I'm inheriting entity, so the ready function here, if I didn't include super._ready and I go down to scripts entity and I find ready, which is somewhere in here, it wouldn't actually add it to the group entity. So I was wrong. It in fact is an entity, so it can take damage. It is not invincible, so I could destroy this blacksmith if I hit it with enough fireballs. What I was getting at was in this blacksmith.gd, he wouldn't be an entity and he wouldn't have the functionality from entity that is instantiated when the ready function is called if I didn't call this super_ready. So I add him to interactable, and then I add an interact function, and then I have to be able to actually have my player handle that interact function correctly. So what I do is inside of my player, so there's be entities, which is structured exactly like the blacksmith, just with different code. I have a get collisions function, tell me what I'm colliding with, and I have an interact function, which is just going to say if I'm touching something in get collisions and it has an interactable tag, then call the interact function on it. So that covers what you need in order to build the home scene. And now for the dungeon scene, you'll notice we have an NPC who's moving and he's shooting fireballs, and we can actually fight that NPC. Well, what do we have to do there? We, similarly to the home scene, we just go to, let's see, we go to the dungeon scene right here. You'll notice there's not a lot in here, but we do need to spawn the current player. Now I did that dynamically by creating a spawn function up here. You can do it in any way that you want, so you could actually just drag and drop the player into each dungeon. That's fine. So I could go, we go to dungeon, entities, player. I could actually just drag and drop the player into dungeon, and that's one way to spawn him. You just have to remember to do that for every single stage, and that can get a little bit tedious, and it's harder when you're doing dynamically generated stages, but it will work. So with the dungeon, we spawn the current player, and then we have this other thing right here, and it's called spawn. So this is dungeon room spawn spawn.tsn. So if we go down here to spawn.tsn, you'll notice that there's really nothing in the script. It's actually just a map. So the idea was this is a spawner not for players, but for map elements. And so without spawning in this room, you could call it a room spawner, then we wouldn't have walls, we won't have floor. And part of a roguelike game is you want to dynamically generate, or at least classically you'll dynamically generate your rooms. And so by having a dynamic spawn inside of your game for spawning rooms, as long as you appropriate the rooms and the corridors correctly, you can have a different experience every time someone goes through the game, because you can just randomize them. In this case I only have one room, so there's no randomization going on, but ultimately inside of my dungeon I'm just spawning this room in. And finally, for the enemy here, you'll notice that the enemy is also an entity. So if we go to entities, we go to Goblin, I think it's called Goblin. You'll see it has the same graphics as the blacksmith, just NPC my programmer art. Again, if you want to learn how to make better art, you can look up my tutorials on Godot on YouTube, and I do have some tutorials that cover that type of content. It has a collision shape 2D, it has a sprite just like the player, just like the NPC. Most importantly, it has a script here. The script, just like the player, loads an ability fireball, loads an ability dash. This one has some differences. It has an aggro range and a minimum firing range. So this is the heuristics that are used for its very weak, what you may call an AI, which is really just heuristic based functionality. So when this goblin loads in, it gets added to a foe group. Now the foe group is maybe going to be important later on if you had, for example, automatically targeting abilities. It's not too important right now. It has a global cooldown that is larger than the player, so it's 2 seconds per attack. It has a slow max speed, a little bit slower so the player can outrun it. Current speed, the reason there's a max in current speed is because you may be able to debuff a NPC by reducing its speed. It has a low health of 40 and a max health of 40, so the current health reaches 0. The reason there's a current and max health is because if your health was at 20, an enemy may be able to heal themselves. This should be starting to make sense. It does not regenerate health, and right here I've defined what it drops when it dies. So in this case it drops a gold amount of... Now, the move towards right here does something very simple. It looks up the player's global position and it basically says dash.execute. So dash is the move ability that this is using, and it's just an ability in here. We could apply it to player. That's the cool thing about having a modular ability system, is that you could have 1,000 different abilities on your enemies, and as long as it's coded in a modular way, once you defeat that enemy, you could give that ability to the player as an optional ability. See, this is a very simple movement system that works only in one direction, which is towards the player, regardless if that's diagonal or horizontal, etc. Versus the player has a little bit more complex move system that lets it go in a lot of different directions. But because they're both coded in this modular way, you could give the player the same abilities as the goblin if you wanted, and more games should do this. It's a little bit more difficult to code your abilities this way, but once you get it down, it's quite simple. So the goblin has a fireball, he has dash, and then what he does is every physics tick, so 60 times a second, he's going to say, well, where's the nearest player? Let's get the current player using that global game master script. And then what we're going to do is we're going to call this act function. What do we do in act? Well, it says, let's find the distance to the nearest player. Let's do some math based on the aggro range. So, you know, how far away, how close does the player have to get before the goblin starts attacking them? You don't want them to attack, if it's a large map, just everything attack at once. And then, of course, what's the firing range? Like, how close should the goblin get before it starts shooting abilities? All in all, you end up with a game that works like this. If I get close enough, as you can see, it'll start following me. Theoretically, if I get far enough away and I run a little bit faster, it'll actually stop following me. I don't know if I can get far enough away with a map of this size. And it's only going to fire fireballs within a certain proximity. And then, of course, if it dies, it drops the gold. I get the gold. And that is really the fundamental features that you need in a roguelite game, all built in Godot in about 2 hours. Like I said, it might take you a little bit more. But, you know, I really just did this because I want to showcase that Godot 4 is still very powerful. It's a little bit cleaner than Godot 3. And if you're getting interested in game development as a hobby, I wouldn't call myself a hobby game developer. Maybe I would. I'm not spending a lot of time developing games, but when I do feel the need to try something like this for recreational fun, I have found that Godot is, you know, really a pleasure to work with compared to the other game engines out there, at least when it comes to these simple weekend projects. Maybe it doesn't meet what's the requirements of an enterprise application or an enterprise game with a lot of developers working simultaneously, but for a simple game like this roguelite, I think Godot is really excellent, and I really like promoting good software, so I think you should give it a shot, and I hope you liked this short and to the point tutorial.